So again, we're looking at different angle measures within our circle, except this time your angles aren't going to come from the center of the circle. Okay, so your angles aren't going to be on the center of the circle. They're going to be kind of all over the place. So first off, I do want to go over what a secant is. So a secant is a line that intersects a circle in exactly 2 points. So yesterday we went over what a tangent was. So a tangent was a line that intersects your circle in 1 point. A secant intersects your circle in 2. That means it has to go through the circle. So at the right there, lines J and K are secants of circle C. Okay, so line J intersects this circle C at 2 points here, and K, same thing, intersects at 2 points here. Secants don't have to go through the center of the circle, they just need to intersect in 2 points. Alright, so with our angle measures that we're going to go over today, first one we have is if we have two secants intersecting inside of a circle. Okay, so this section is intersections inside a circle. Okay, so when two secants intersect inside a circle, the angles formed are related to the arcs they intercept. So we're going to have to look at the arcs intercepted by these secants. So our first theorem here today states if two secants or chords intersect in the interior of a circle, then the measure of an angle formed is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. What's a vertical angle? Are you raising your hand or are you just, okay. What's a vertical angle? So a vertical angle.
It's an angle that's vertical.
An angle that's vertical. You have two intersecting lines. Yep. The angles. It doesn't have to.
It does.
Okay.
You said vertical.
Yep. Angle, not a line.
It goes up and down.
Your two angles across from each other. Those angles are going to be congruent, right? Okay. So if I look at my picture on the right here, and I look at angle 1. Okay, its vertical angle would be this angle right here. Okay, so it's the angles across from each other with your two intersecting lines. Now those two angles are congruent. So what we can do to find their angle measure is take the arc that angle 1 intercepts. Okay, the arc that angle 1 intercepts, that would be arc AB. We're going to add it to the arc that its vertical angle intercepts. Okay, so that would be DC. Okay, since those two angles are congruent. So we're taking their arcs intercepted, you're going to add them together, and then you're going to divide it by 2. So to find the measure of angle 1, what I would do, take that arc intercepted AB, add the arc intercepted by its vertical angle, which is arc DC, and take half of that sum. So divide by 2. Okay, so that's the formula that we're going to use when we have two secants intersecting inside of the circle, okay, to find that angle measure. So we're going to go through some examples of that. So 1A, we want to solve for x. Okay, x is that angle. So what I want to do is find the arcs intercepted by that angle. So that would be arc LK. Okay, so if I follow that angle's rays, okay, follow those rays, it hits at point K and point L. That's how I found that arc LK. Next, I need to look at its vertical angle, so the angle across from it formed by those two segments or lines, and see what arc that one intercepts. Well, it intercepts this arc HJ. Okay, so to find x, which is the angle, I'm just going to plug in what I have into this formula here. So x is the angle. I need the two arcs intercepted, or the ones that I highlighted. I need to add those together. So 116 plus 47. And then I need to divide by 2. Okay, you should get x is 81.5 degrees. Okay, questions? All right, 1B. This one's a little bit different. So my angle or x that I'm looking for is this one right here. Well, if I try and find the arc that's intercepted by that angle, it would be MN. But I don't have a measure for that one. And if I look at the vertical angle, I also don't have a measure for that one, right? However, if I look at these two arcs, I do have measures for those ones. Okay? So what I can do is find this angle here. Okay? So we'll find this angle here by using this formula, taking our two arcs, adding together, dividing by 2. Then what I notice is that x and y form a straight line. So what could I do after I find that angle? Not equal? Yes, you can subtract it from 180 then. So first I'm going to find this angle. So to find angle y, we're taking our intercepted arcs, which is 75 and 55, and dividing by 2. Okay, so that angle y is 65 degrees. Now again, that's not the angle I was looking for. So what I want to do is find x. And to find x, since they form a straight line, we'll take 180 and subtract that angle from it. That's 115 degrees. Okay, does that make sense? All right, last type of problem you'll see with these two intersections is 1C. Okay, this time your x value is one of your arc measures, okay, instead of the angle measure. However, we're still just going to use this formula. Okay, so where it says the measure of angle 1, I can plug in my angle measure. Okay, so with that angle, my arc intercepted is WY, right here. And its vertical angle's arc intercepted is the one labeled as X. So those are the two arcs that I'm going to use. So just plugging my values into this formula, I have my angle, which is 128. Oops, that's an 8. 128. That's equal to our first arc intercepted by that angle is 154, plus our second arc intercepted, which is x, and that's divided by 2. From here, all I have to do is solve for x. So I'm going to multiply both sides by 2. so that they cancel on the right here. That's 256 is equal to 154 plus x. Then I just have to subtract 154 to get x is equal to 102 degrees. What? Why?
Well, I did it like in 3 steps.
Okay.
No, I did, you can multiply 128 by 2.
That's what I did. That's what I did.
But
I just
that's
wrote
way
it down.
more complicated than doing that.
However you need to think about it, Garrett. All right, so that's your intersection of two secants, and that one's inside of a circle. Okay? Our next one that we're going to go over is an intersection on the circle. Now, if you remember, we already talked about intersections on a circle, right? Okay. When we talked about intersections on a circle, we had an inscribed angle. If I had that inscribed angle, and I already had the arc that was intercepted by that one, what did we do to find that angle? If I have an inscribed angle and I want to find that inscribed angle measure, right? That's an angle that's on the circle. If I was given the arc that's intercepted by that angle measure, how do I find the angle? You divide it by 2. That's what we're going to do here because it's an intersection on the circle. Okay, so if a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is 1/2 the measure of the intercepted arc. So I get my intercepted arc for angle 1 is from B to A. Okay, so that point A is your point of tangency, and point B is where that angle intercepts that arc as well. Okay, so you have this arc intercepted by this angle. So all I have to do to find the measure of angle 1 is take my arc, AB, and divide it by 2 since it's an intersection on that circle. Your angle, the vertex is on the circle. Okay? So going over these types of examples here in 2A, we want to find the measure of arc JLK. So arc JLK is this arc right here. Okay, so again, when you're looking at arcs, those points go in order. Now, I'm given this angle HJK is 116. So again, just using my formula I wrote down, plug in your angle. So we have 116 is equal to the arc intercepted, which is JLK, or X if you want to label it X is fine, divided by 2. So then just to solve for that arc, multiply by 2. Now if you understand that and don't need to write that step down, you don't have to. Okay, so the measure of arc JLK will be equal to 232 degrees. Okay, next one, 2B. We want to find the measure of angle RQS. So that's this angle right here. Now we're given that arc QTS, so from Q to T to S is 238. Okay? What I want is this arc QS so I can find this angle. Well, if I have this arc, how do I find this arc? I heard somebody say it. Take 360, which is your total circle, subtract 238. To get this arc is 122. So now that I have that arc intercepted, I can find that angle. So using my formula again, solving for the angle, I labeled it as x. Take your arc intercepted, that's 122, divided by 2. So the measure of angle RQS will be equal to 61 degrees. Okay, questions on intersections either inside a circle or on the circle? All right. Last section. Intersections outside the circle. Divided by 4. Okay, so next we have these intersections outside of a circle. So we had inside, on, and now outside. Okay, so secants and tangents can meet outside a circle. The measure of the angle formed involves half the measures of the arcs they intersect. So again, we're going to take half of these arcs. Now, when you have two secants, a secant and a tangent, or two tangents intersecting in the exterior of a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. What's the difference mean? Subtraction. Okay, so instead of addition, now we're going to subtract. Okay, so I have my 3 different examples here. This one is 2 secants, a secant and a tangent, and 2 tangents. Okay, it's basically the same formula for each. Okay, so with 2 secants, you need to follow your rays at which arcs that they intercept. Okay, so first one here, they intercept this little arc, BC. Okay, and if I keep following, it would intercept this arc right here, DE. Okay, so what you would do to find angle A in this case, okay, so solving for the measure of angle A, you need to take your larger arc or the further arc that's intercepted, okay, the larger one or the one that's furthest away from the angle. So in this case, DE, subtract it by the smaller arc or the closer arc, which is BC, and then divide it by 2. Okay, same thing with a secant and a tangent. Now, with your tangent, you do have this point of tangency here, C. So there are 2 arcs that are intercepted by these lines. So the first arc, if you follow the lines again from your angle, would be B to C, because it hits at point C there. Okay, so that's your first arc. Okay, second arc intercepted, again I hit at C, but then this one hits at point D. So the second arc intercepted would be CD. Okay, and it's the same formula. So to find angle A, you'll take your further arc or the larger arc intercepted. In this case, that would be DC. Subtract by the smaller arc or the closer arc to that angle, which is BC. then divide it by 2. Okay, last one is 2 tangents. So again, in this case, tangents, you have point of tangency at C for this line, point of tangency at B for this line. So again, it splits this circle into 2 arcs. So following our lines from A, first arc intercepted is BC. Okay, that's this one right here. Second arc intercepted is this larger arc BDC. Okay, so BDC. So yes, it looks like the full circle. But again, to find angle A, you're going to take the arc further away that's intercepted, or the larger arc, which is BDC, subtract the smaller arc, or the closer arc intercepted, which is BC, and then divide by 2. Okay, so all we're doing is taking the larger arc, subtract the smaller arc, divide by 2 to get the angle. Okay, questions before I start any examples here? Yes, Alex?
Would I get a different answer if I did it the other way around? Like I put
The smaller arc, you'll get a negative.
Okay.
So yes. All right, so looking at our examples here, number 1, we want to find the measure of angle L. So we're looking for this angle right here. Okay, this one you have 2 tangents that intersect outside the circle. So I have a point of tangency at H and at K. Now I'm only given arc KH. Okay, that's 102. To find this angle, I need this arc HJK. How can I find that arc? If I have this arc HK. Subtract it from 360. So take 360, which is the total circle. Subtract the arc you know, to get this larger arc here of 258. Okay, so now that I know my 2 arcs intercepted, I can find the measure of angle L. So just using our formula here, finding the measure of angle L instead of A, we'll take our larger arc, that's 258, subtract our smaller arc, 102, then divide it by 2. To get the measure of angle L is 78 degrees. Okay, then number 2, we want to find the measure of arc CD. Okay, so that's this arc here. We have a tangent, AC, with your point of tangency at point C, and a secant AD that's intersecting at point B and point D. So I'm trying to find this arc here. When I'm given angle A is 56 and arc BC is 95. So I'm just going to use our formula. This one's the secant and tangent. Plug in our angle. Angle A is 56. Okay. Plug in our larger arc. Okay, our larger arc is what we're looking for. You can say it's X. You can still label it as CD if you want. Okay, doesn't matter. Then we need to subtract our smaller arc, or the one closer to the angle. That's 95. then divide it by 2. Okay, and I just have to then solve for arc CD. So I'll multiply both sides by 2 to get 112 is equal to arc CD minus 95. Then I just have to add 95 to both sides to get the measure of arc CD is 207. Okay, questions on 1 or 2? How I use those formulas, anything like that. Okay, so again, you have intersections inside, intersections on, and intersections outside. Okay, you need to look at your picture and decide what type of intersection it is so you know what formula to use. Okay, there are, I think, 2 problems. Okay, I have to remember how they look here. You have a circle. They are intersections outside. Yeah. They're 2 tangents. Like this. Okay. They give you what the angle measure is, I think. Okay, so they give you, we'll say it's 30. They give you the angle measure. They don't give you any arcs, and they're asking you to find an arc. Okay, so what I would do, find your points of tangency. Label the arc they're asking for as X. So whatever arc they're asking for, label it as X. So let's say they're asking for this smaller arc here. I would label that one as X. The other arc then, yes, you would label as 360 minus X. And then plug that into your formula. Okay, so you would say 30 is equal to 360 minus X divided by 2, and then solve for that X value, and that would be your arc. Okay, I believe there's 2 problems, 2 or 3, at least 2, on your assignment that are like that. So if you're not given those arc measures, that's how you should label it. Okay, does that kind of make sense? Any questions before I let you work on your assignment?